In this project, I will show you how to predict if these images correspond to a tidy or non-tidy room. It will be a nice excuse for doing deep learning in Keras and Python. On the left you can see two images when the room was not tidy, and on the right you can see two images when the room was tidy. The non-tidy images will correspond to situations where the floor is full of toys. In this example I collected the images myself, but these images could otherwise come up from a video surveillance system or even a robot that is monitoring the house and taking pictures from the floor. Anyway, for this exercise I will train a fairly simple model in Keras using Python. I will use prython 1.80 as my IDE, which can be downloaded from here. You can download my project from the following GitHub link. Bear in mind that you need to download the images from here as well. We have a few hundred images for each class, and the objective of this project is to classify these images with an accuracy of over 90%. Will we be able to make it? We'll see. Fortunately, these images have very good resolution of 375 by 500 pixels, which is quite good for deep learning. Prython will be the ideal IDE for this because it will allow me to separate my Python code into panels and then connect them as I want. In this first panel I will load and prepare the data. Note that I am reading the images using the standard imread function, which is a standard Keras function. It will bring the three channels, red, green and blue. So every image will have as many pixels as its height and an extra dimension equal to 3. The two loops will scan the tidy and non-tidy directories and put things into two lists. We will then put the two lists together. Basically, I am concatenating all the images together into a big list of images. Then I just call numpy and tell it to transform the list into a numpy array. On the right we can see all the numpy array's dimensions. We have a 500 by 375 by 3 for a typical image. Our array of images will then be 412 by 500 by 375 by 3 because we have 412 images stacked together. In order to generate my target array, I am calling toCategorical to cast a vector of zeros and ones for the tidy and non-tidy indicators into a two-column array with zeros and ones. It will have two columns, one for the tidy images and another one for the non-tidy. So, just to sum up, this X array will contain all the images and Y will contain the targets. I will formulate my Keras model here. This is connected to the out part of the previous panel, meaning that it will use every object defined in there. The very first thing here, I am defining a callback for my model. This callback will be called every time an epoch finishes in my model. The reason I want this is because I want to print a status. Prython will automatically parse whatever is printed here and will build a progress bar for me. In order for this to work, Prython needs the format to be exactly the one that I have here, starting with progress plus a number between 0 and 1, and then a slash and the name that we want to use. You can, by the way, create multiple progress bars for each panel, which is especially useful when we have nested loops and want to track external and internal loops. I will first split my data into train and test. I will then feed that into Keras. The setup is pretty standard here. This is a convolutional neural network with a bunch of 2D convolutions stacked together plus some max poolings. Nothing weird here. Maybe we need to comment on the strides. I am using 2x2 in order to reduce the model size. I use less parameters. As an exercise, try to play with those numbers and see if you can get a nice model with bigger strides. We finally compile. We want a binary cross entropy as loss because we only have two classes. I will then pass the train and test datasets with verbose equal to 2, and I will also print a summary. So after this panel I have three predictions as examples, which I will explain in a minute. For the time being I just want to run this. How do I do this? I press in here and this runs everything that is connected to the out, meaning everything that uses these panel objects. Wow, 7 million parameters is a lot for a simple exercise like this. It is likely that we would do equally good with less parameters, but we will leave that for another occasion. Look at this, Prython shows Keras metrics in real time. This is beautiful, no need to configure TensorBoard or things like that. In Jupyter, this can be done manually by creating a callback and calling matplotlib and then refreshing that. But that still needs some work. In other IDEs, it is much harder. As we can see, the accuracy gets up for both training and testing. Same for the loss, keeps going down. Interestingly, I don't see any warning signs about overfitting. If we had overfitting here, we would see a discrepancy between validation and training data that I am not seeing. Also look at the progress bar automatically shown by Prython. I can see how much time is remaining. One interesting thing is that after 7 epochs we are just fine, and probably no more training is necessary. The predictions are quite easy, we just need to accommodate the images in a right format and do the predictions. This is a pretty standard model.predict. As usual in Keras, because my target had 2 columns, one for the tidy images and another one for the non-tidy ones, my predictions will have 2 columns. I just need to select the one with the largest value or probability. This is why I called numpy.argmax. I will grab 3 of them and put them into separate panels just for the sake of clarity. As you can see, our model predictions work really well. Out of the 3 images, I am predicting the 3 of them correctly. In order to show the images, I simply call matplotlib and then call the .show method to show them.